In direct variation, the equation is y equals kx. This means that y varies directly as x. Y is directly proportional to x, where k is the constant multiplier. So you would be able to find k, the constant multiplier, by doing y divided by x, because we know that y is directly proportional to x in this equation. Y over x would equal k. If an equation can be written in this form, let's take 2x plus 3y equals 0, subtract 2x from both sides. We get 3y equals negative 2x, divide both sides by 3, and we get y equals negative 2/3 x. This can be written in the form y equals kx. The constant multiplier k is negative 2/3, so yes, this represents direct variation. If we follow those steps to solve for y in question 2, we would subtract 5x from both sides, get 6y equals 30 minus 5x, divide everything by 6, and we would get y equals 5 minus 5/6 x. This is not in the form of y equals kx, so this does not represent direct variation. Looking at a table of values, any y value divided by the x value would give me the constant of variation. 1 divided by 2, that's a y value divided by the x value in this ordered pair. 1 divided by 2. 0 divided by 0 would be 0. We know we're going to get 0, 0 as a point on the line for any direct variation because k times 0 will always equal 0. Look at another point, negative 1.5 divided by negative 3. Is that also equal to 1/2? Negative 1 divided by negative 2 is also equal to 1/2. When I check every y divided by x, do I get 1/2? If so, I know that I have direct variation and the equation is y equals 1/2 x. When I look at question 6 and try the same thing, I've got the 0, 0 point that I expect. But when I look at negative 1 divided by 1, does that give me the same answer as negative 4 divided by 2 or negative 9 divided by 3? Since these each give me a different answer, I do not have a constant multiplier. There is no constant of variation, and this would not be direct variation. The same thing happens with a graph. We can take the xy ordered pair. In this case, we have 3 comma negative 2 and negative 3 comma 2. We know that for all constant multipliers, y divided by x will give me the same answer. So if I do 2 divided by negative 3, is that the same answer as negative 2 divided by 3? Yes. So my constant multiplier is negative 2/3, and I can write the equation y equals negative 2/3 x. Whereas here we have the points 1 comma 2 and negative 3 comma negative 4. When I do y divided by x, 2 divided by 1 is 2. Negative 4 divided by negative 3 is positive 1 1/3. This is not a constant multiplier, so this would not be direct variation, and therefore it cannot be written in the form y equals kx. Here we have 3 comma negative 1, and we have negative 3 comma positive 1. Both give me negative 1/3 when I divide y divided by x. So my constant of variation is negative 1/3, and my equation is y equals negative 1/3 x. Knowing its direct variation and given one point on the line, like negative 3 comma 5, We can do y divided by x to find our k value. So our k here would be 5 divided by negative 3, or negative 5/3. My equation is y equals negative 5/3 x. I know that if x is 0, y is 0. I know if x is 3, negative 5/3 of 3 would be negative 5. So I'm able to find other points on the line using the equation that I've written for direct variation. So given my xy ordered pair, negative 2 divided by negative 4 is equal to 1/2. That's my constant multiplier. So the equation is y equals 1/2 x. If I know that, I can plot points by doing half of x. So half of 2 is 1. Half of 4 is 2. Half of 6 is 3. Half of negative 2 is negative 1. Half of negative 4 is negative 2. Half of negative 6 is negative 3. So this would be the line to represent that direct variation equation. Knowing that y varies directly as x, you can divide the y by the x value to get the constant multiplier. So negative 16 divided by negative 4 gives me 4. So I know the constant of variation is 4. Once I know the constant of variation, I write it in the equation y equals 4x. If y is equal to 4x and they give me the x value, then I know y is equal to 4 times that x value. So y equals 4 times negative 5, which is negative 20. Here, if they ask me for the x value and I know y, but I have the equation, I can say 12 equals 4x, divide both sides by 4 to get an x value of 3. When x is 3, y is 12. Now we have other points on the line that would also be proportional to the given negative 4, negative 16 point we started with, because y is proportional to x in this situation. So y divided by x, negative 8 divided by 6 is negative 4/3. That tells me my constant of variation and leads me to my equation. Once I have an equation, I can use that equation to find other points on the line. Negative 4/3 times negative 3 is 4. And if I'm given the y value, I can set up the equation negative 8 equals negative 4/3 times x. Multiply both sides by the reciprocal to get negative 8 times 3 over negative 4 for my x value, which would give me 6.